resume this. All right, so what can I help you with today?
On the homework from Tuesday night, could we go over number 4?
Yes. So Tuesday night, was that the review or a word problem one?
That was the word problem one.
Okay, let me see if I can pull that up real quick. Okay, word problems. Oh, the dunk a basketball one, is that right?
Yeah.
Okay. Yeah, so let's see if I can, well, let me move it up much higher. I wonder if I could do this. I wonder if I could, I'm gonna try something. Oh, I don't think I can. I was gonna try and like cover all this up, like with a white box, but I don't think I can fill the box in. So then I could write up there. Anyway, whatever. I'll work around it. Okay, so let's read. You need to jump 2.5 feet in the air to dunk a ball. The height your feet are above the ground at any time t is given by that function. What's the maximum height your feet will be above the ground? Will you be able to dunk the ball? Okay, so I'm actually going to, go to, let me just copy down their equation real quick. Negative 16t squared plus 12t. All right, I think it'll be easier to do it with just a whiteboard. Okay, so the equation was negative 16t squared plus 12t. And the question is, can you jump 2.5 feet, right? 2.5. So that's kind of our, we need to keep that number in mind at the end. All right, so think about what's going on. Here's the ground. Here's your feet, right? You got the basketball. Oh my gosh, whatever. It looks like an alien. But anyway, there's your feet. You're going to jump up and try and make this basket. So this equation models that parabola, the shape that your feet are going to take as they leave the ground. So we want to know basically what's the highest height your feet are ever going to get. And if it's 2.5 feet or higher, then you know you'll be able to dunk the ball. And if it's not, then you can't, right? So in order to find how high this is, I'm really looking for the y coordinate of my vertex. The x coordinate will tell me how long it takes you to get up here, but the y coordinate will tell you how high you actually get.
Okay.
So I have the equation up there. I'm going to do, to find my vertex, I'm going to do the negative b over 2a. So that'll be a negative 12 over a negative 32. So 12 over, oh wait, no, not 32. Yeah, 32. Yeah, I'm right. Okay. Negative b over 2a. So that reduces to be what?
3/8.
3/8, yes. So that would be, it would take you 3/8 seconds to get up that high. But again, that's not what I need. I need to take 3/8 and now pop it back into this equation.
Okay.
See what comes out, okay? So it's annoying that it's a fraction, but we'll figure it out. So we're gonna find what is the height at 3/8. So negative 16 times 3/8 squared plus 12 times 3/8. Okay, so 3/8 squared is going to get me a 9 over 64. And then 12 times 3/8. Okay, so let's see what we can do. We could reduce a little bit first if you wanted, by 8 maybe. 8 goes into that. That would be a negative 2. 8 goes into that 8 times. Oh, I can do it again. That would just be a 4. So that's just a negative 9/4. Do you agree with that?
Yes.
And then over here I can reduce. Let's see. 4 goes into 12 3 times, and 4 goes into 8 twice. So that would be 9/2. Okay, so now I want to add these two fractions together, but they're not common denominators, so I'll just multiply this one by 2/2. So I really have negative 9/4 plus 18/4. So I get out 9/4. Now 9/4 doesn't mean a lot, but when you go back and think about what this problem is asking, I'm trying to find how high I ever get. So if I turn 9/4 into a mixed number, isn't that 2 1/4 or 2.25?
Yeah.
Oops, I'm writing off the thing here. So yeah, 2.25 as a decimal. So that's the highest my feet are ever going to get off the ground. And I remember needed them to be 2.5 feet up. So can you dunk the ball?
No.
No, unfortunately. Was there another part to that question, or was that it?
That was it.
Okay, perfect. Does that all make sense?
Yeah.
Okay, great. All right, what else you got?
Could we go for number 7?
Yeah. So let me see. Let's pull up 7. Okay, 7. Okay, so this one does have 2 parts. They want to know how much does it cost to produce 100 crates of pencils, and how many crates of pencils will minimize the cost of production. Okay, so for part A, all right, so they give us this equation for modeling the cost of producing the crates of pencils. If I want to produce 100 crates, now the 100 crates, if you see right, can I write on this? Yeah, I can. So X represents crates, and I want to know 100 crates of pencils. So all I have to do for the first one is just plug in 100 for X and see what comes out. And that'll tell me what my cost is if I were to want to create 100 pencils. Okay, so if I go ahead and pop in 100, I'm just going to do it on my calculator real quick. Let's see, I'd have 1/2 times 100 squared minus 10 times 100 plus 1,000. So I get 5,000 for that first answer. Did you get that?
Yeah.
Okay, perfect. So now in the second one, in part B, how many crates of pencils will minimize the cost of production? So many of the other questions ask you about a maximum, like the last one, how high would our feet ever get? This one's asking about a minimum, which just means that this parabola is going to have a min instead of a max. So if you take a look back at, remember how if A is positive, this whole thing's going to be up like a cup?
Yeah.
This parabola is going to look more like this. So it's actually, I'm still looking for the vertex, it's just that it's going to be the lowest point. Okay, so they want how many crates of pencils. So remember, that is X. Will minimize the cost. So I don't actually have to fully find the vertex on this one. I can just find the X coordinate because that's all I need. So let's go ahead and do negative B over 2A. Oops, negative B over 2A. Let's see if I can fit it in right here. So it's going to be a positive 10 over, oh yeah, I definitely can, because 2 times A is just 1. So my answer is just 10. That's it.
Oh, cool.
Yeah. I love these ones. Any other ones?
Number 10.
10 on the same sheet?
Yeah.
Okay, the function represents the yearly income or loss from a real estate investment where T is time in years after 1970. During what year does the maximum income occur? Okay, so T is time, which is really, if we're thinking X's and Y's, that would be our X value, right? During what year does the maximum occur? So I really want my x coordinate of my vertex again for this one. Okay, so let's see. Negative b over 2a in this case. So that's going to be a negative 1.9 over 2a. So that would be a negative 0.2. All right, and then, so that just comes out to be a positive 9.5. Okay. So during what year does the maximum income occur? So that's going to be 9.5 years after 1970. So that year would be 1979, right? We'd be 6 months down the line in 1979.
Yeah.
Okay. And then part B asks, what is that maximum income? So all I have to do is go ahead and take that 9.5 and plug it back in for T. So again, I'm going to ask my calculator to help me with that. So a negative 0.1 times 9.5 squared plus 1.9 times 9.5. Oh, did I mess up? That doesn't seem right. Did you get 9.025?
Yeah.
You did? That
Mhm.
doesn't seem like a... Maybe this is in thousands of dollars? Oh, it doesn't specify. Let me double check. Was 9.5 right? Is that what you got?
Yeah.
Okay, so that's right. Let me type it. That just seems so weird. Negative 0.1 times 9.5 squared plus 1.9 times 9.5. Yeah, that's right. 9.025. I just don't know if it's got to be, if we're talking about yearly income from a real estate investment, $9.03 doesn't make sense. But if it's in thousands or hundreds of thousands of dollars, maybe that makes more sense. But the problem doesn't specify. But anyway, so yes, I get the 9.025. I can't write it where B is because like my menu bar's in the way. So that goes down there. Oh, that's a weird one. Okay, what else you got?
Um.
How was that review?
Could we go over number 12 on the review?
Of course we can. Oops, I clicked the wrong thing. Oh dear, oh dear. I need this. Okay. Algebra 3, quadratics, review. Okay, I'm sorry, which number?
12.
12. Okay, yes. So we have 1, 0, and it has a maximum value of 4. Okay. And what are we doing with these? We're finding the quadratic, show all your work. Okay. So I'm gonna, let's see, if I sketch this out a little bit. Oh. So here's what I know. 4 plus root 3, let's just see what about that is as a decimal. 4 plus the square root of 3. Oh, geez Louise. Big fingers. Okay, that's about 5.7. All right, so I know this thing is going to cross the axis here. 4 plus, oops, root 3. Okay, and then I also know its maximum value is 4. So the highest it's ever going to go, but I don't know. Oh, yeah, it's hard to sketch this one because I don't know if it's going to go this way or it could go this way. I don't know. Well, let's just guess that it's going to go something like this. And the highest value is going to be at a 4. Oh, gosh. Huh. I'm kind of stumped unless you use its other, the conjugate as your other zero. Hang on one sec. Let me just look at my key. Oops. Oh, see, on the notes I say that the maximum value is at 4, 4, but how did I know that? Oh, I know. Okay. Never mind. Sorry. Early in the morning. All right. So, but yeah, you wouldn't know this yet because I don't think you've done this yet. So anyway, when you have a complex number as one of your zeros, its conjugate always comes as a 0 as well. So, do you remember how to find the conjugate to something like that? Like, for example, if you had 4 plus root 3 in the denominator and you wanted to rationalize that denominator, do you remember what you multiply by to undo that?
You it's like coming back to me because like I remember, but like I can't think of it.
Yeah. I hear you. It's the same thing, but you change that middle sign to a minus.
Yeah.
So that's called the conjugate, okay? So one thing that we're actually going to learn in the next section, which I probably would have taught you this in real life already, but that's okay. When you have a 0 that is one of these numbers, its conjugate automatically is also a 0. So that's how we can get the other one. Okay, so 4 plus root 3 is a root. Oops. Then 4 minus root 3 will also be a root.
Mm-hmm.
Also a 0. Okay, so now I have my two x-intercepts. I have the 4 plus root 3 and the 4 minus root 3. So now, if I were to look at that, I don't know where they land. Let's say this is the 4 minus root 3, and this is the 4 plus root 3. There's still an infinite number of parabolas that are going to go through this, right? I could have one that looks like this. I could have one that looks like this. So I still need to narrow it down. Just having the two x-intercepts isn't enough. So they gave me this other little bit of information that the maximum value is 4. So again, I don't quite know what y that's at, but I can find it. So doesn't the vertex have to happen, since everything is symmetrical, the vertex has to happen halfway in between those two values. Would you agree with that?
Yes.
Okay, so to find what that x-coordinate is, I can add those two values together and divide by 2. So if I add 4 minus root 3 and 4 plus root 3 together, so let's see, that would just be 8, right? Because the root 3s are going to cancel. So
Yeah.
I'd get 8, and then I divide it by 2. That means that this point right here is at 4. And that's how I knew that this point was at 4, 4. Oops, there we go. Does that make sense?
Yeah.
Okay, so now I have pretty much all the pieces that I need. I have a vertex, so I could do this in vertex form, and I have the two x-intercepts, so I could do it that way. I don't know. I'd probably do the x-intercepts. So remember the formula for that was a times x minus p times x minus q, where p and q are just those x-intercepts. Okay, and then we will have to figure out what a is, but we'll do that in a minute. So first, let's plug in p and q. So I'm going to do x now. Be careful because you have to minus all of this. So if I subtract that whole thing, it's going to look like this. Minus 4 plus root 3. And then if I do the same thing with this one, I'm going to subtract that whole thing. So it's going to be x minus 4 minus root 3. Oh, I'm running out of room. Okay, so let me write this over here so it's a little bit bigger. But at the same time, why don't I go ahead? I'm going to have to solve for a. So I'm going to plug in 4 comma 4 for x and y, and then right into this whole big crazy equation. Then that way, once I plug in 4 comma 4, the only thing that'll be left to solve for is a, and I should be able to. Okay, so y is going to be 4. A is what I don't know. X is 4 minus 4 plus root 3. Then my other parenthesis, if x is 4 again, minus 4 minus root 3. Okay, now if I just sort of simplify all this, it's going to come out to be a little bit cleaner. So let's look at this first parenthesis. 4 minus 4 is just 0 plus root 3. So that just leaves me with a root 3 in there. And then my second parenthesis, 4 minus 4, again, just goes away, and I'm left with a negative root 3. So positive root 3 times a negative root 3 means that I'm just getting negative 3 right there, right? Because the roots are going to cancel out. And then I can just divide both sides by a negative 3. So now I have a. It's a negative 4/3. All right, so now I can put it all back together and make my equation look nice. So let's see. I can do it down here. So if I go right back to this guy, I can pop in all those pieces. So y equals a is now a negative 4/3. And then I'd have x minus 4 plus root 3. And then x minus 4 minus root 3. Okay, and you could leave it like that if I don't specify what form your answer has to be in. So you could have also popped this into, once you found out what a was, you could have plugged it into vertex form, since you know what the vertex is. Or you could multiply all this out and get it in standard form. So whatever floats your boat.
Mm-hmm.
Does that make sense?
Yes.
Okay. All right, any other ones you want to do?
Actually, I think I'm all good.
Yeah, okay. Yeah. All right. How'd you feel about the solving in 3 variables?
Good.
Yeah. Okay, good. Those can be so frustrating because if one thing is wrong, it just messes everything up. I had a few kids that were just, every one they would try, there's just one tiny little thing. They could just drop a negative or you added wrong.
Yeah.
Those are frustrating. But anyway, okay, good. I'm glad that you were good with those. All right, my dear. Well, thank you for joining me again.
You're welcome.
All right, I'll see you later. I hope sometime.
Okay.
Bye.
Bye.